ahead. So let us continue. I'll just give a brief introduction about me for those who are not there. I'm a senior software developer at Enterprise DB, and I'm going to be talking about partitioning. I'm going to give a summary of what all the features the PostgreSQL provides, and then also give some performance numbers on how it behaves in various scenarios. So let's begin. First, I'll be just giving an introduction about what is partitioning, what are the key terms that we use in the partition terminologies, and then the partitioning benefits that we can get by using this feature. So what exactly is partitioning? Partition is simply what the name suggests. You are going to divide our data of a particular table into smaller parts or smaller tables. But in this case, what the application or the user will see is still a single table. He will still be firing queries on a single table, but internally, you are able to target small different tables individually, which gives you a lot of benefits in various scenarios. Now, the key terms when it comes to partitioning, the first one I would say is a partitioned table. The partitioned table is basically the parent table in which itself will not contain any rows or data, but it simply redirects the data to child tables, which are called partitions. And the partition key is basically a column or multiple columns based on whose value you will determine which partition this particular row will reside in. The partition bounds is basically the restriction of each of the partition, which determines the rows that are contained in the partition. Like in this particular example, the first partition can contain rows that have values from 1 to 10,000. So that's the partition bound of that particular partition. So that is partition bounds, and it is different for each partition. I'm sorry. So few of the partition benefits you could say is data segregation. It kind of provides data segregation. You can divide data based on time and different qualities. So it will happen that you would have some data which is more frequently accessed than some other data. So you can move those most frequently accessed data to a very fast disk so that the performance of your overall system is quite good. And yeah, I'm sorry. Yeah. So the second one is maintenance. So you have to perform regular maintenance activities on your data to keep your system healthy. And having partitioning enables you to perform maintenance activities on a smaller set of data, and you can perform it parallelly. So in that case, you would actually be able to perform activities much faster than when you have to perform in a whole big table. Obviously, because of these, you can have the database to be better scalable and also have better performances. So there are two styles of partitioning which is supported in PostgreSQL. One is the inheritance or trigger-based partition, which was there since 9.1, and then the newer declarative partitioning, which is recently introduced in PostgreSQL 10. So the problem with this inheritance or trigger-based partition was that it was manual. In that, you have to create trigger on the parent table and also a check constraint on the child table, and you have to manually maintain all this data. So there is no way you can have an automated check to see whether there is the constraints of the child partitions are mutually exclusive, and hence it was very hard to maintain, much error prone, because if you have to remove a partition, you'll have to edit the trigger and then remove the check constraint, and there is a lot of stuff that you need to do to perform a simple operation. So together with this, declarative partitioning provides somewhat an automation in creating partition data, and this has a simpler syntax, and hence you are able to manage the partition easily because the mutual exclusions is handled. If you are providing a partition which overlaps any other data, then it would throw an error, and you no longer have to do the triggers or the check constraints. That is kind of the behind the scenes thing that happens right now. The three partition strategies that PostgreSQL supports are list, range, and hash. So when you talk about list partitioning, This was introduced in PostgreSQL 10, and in this, for each, the partition bounds is you have to explicitly mention the values that each partition can hold. Like in this example, one partition can hold values which are for Delhi, and another can hold for Mumbai and Goa. So you can either specify one or multiple values that a particular partition can hold. The next is range partitioning. This again was introduced in PostgreSQL 10. In this, you specify a range of values that a particular partition can hold. And when you specify a partition range, so saying from 100 to 500, so that particular partition can hold rows which have the value 100, but not of 500, because its lower bound is inclusive, but the upper bound is not. There are two unbounded values, that is min value and max value, which is exactly what it says, that minimum value and the maximum value. So it is basically kind of infinite, negative and plus. Yeah, the third kind of partitioning is hash partitioning. This is introduced in PostgreSQL 11. And in this, you basically run the value into a hash function, basically divide it, and then depending on the remainder that you get, you would determine which partition this row will go into. So this is kind of useful when you don't have a very logical way in which you can create a partition, or it is helpful in those cases where if you have to give a list partitioning, you would be creating multiple small, very small partitions. So you would rather have less number of partitions, but the data has to be evenly arranged. So in those cases, it can help. So this section, I'm just going to be talking about the various declarative partitioning syntaxes that you can use. Starting with how do you create the partitioned table or the parent table. So the new clause that has been introduced is partition-by. So you just write the create table command as it is with all the parameters that you have to specify, and then you just say partition-by and then mention whatever strategy that you would like to use for partitioning in for that particular table and along with the partition key. So like I have given this example for list, range, and hash. So basically, I'm just stated the create table, then whatever restrictions you have, whether you have constraints or anything, you can just mention after it, and then you end it by saying partition by list, and then you mention a partition key. In this case, it's just column 1. Similarly, for range and hash, you simply write the strategy name, whatever you want to use, range or hash. Now, to create a partition, you have the clause partition of, which will mention which table's child this is, and then you mention 4 values and then specify the partition bounds of that particular partition. So for list, you say a create table, partition of the parent table, then 4 values in, and then you specify each of the values that are permitted for this particular partition. Similarly, for range, you would say, after 4 values, you would say from the lower bound for that particular partition and to the upper bound of that particular partition. So in this case, this partition will accept values from 10 to 20. For hash, you would have to specify the modulus and the remainder for this particular partition using the keyword with as specified in the last case. So there is a possibility for you might already have a table which contains a particular data and you would like it to be a partition of another already partitioned table. So you don't need to copy data again or anything. You can simply just add the table to the partition table as a new partition. So that is where this attach partition statement helps. So you just say alter table, whatever parent table you are considering, and then say attach partition, and then you mention the table name, the partition name, and then 4 values, and then you mention the partition bounds like you had done previously. Similarly, you do it here. So I have listed example for all the 3 cases here so that you can use it. One thing in this is whenever you try to add a partition, all the data in that particular partition will be checked whether it meets the partition bounds that you have specified. So if you're going to have a really large table which you're going to be adding as a partition, it can take quite some time because all the entries are going to be checked whether it is meeting the particular bound. So for example, I have attached the new plist, to plist I've added clist2 with the values Mumbai. So it is going to be checking all the entries to see whether actually all the entries do have only Mumbai. Suppose you accidentally had a row which had Delhi, then it would not attach to the partition, it would throw an error. So the amount of time this command will take will depend on the amount of entries you have in that particular table. No, see, there is a way you can create a partition. So if you use the partition of command, so it is already a partition. But you already have a table that you had a standalone table for some reason, which had the same rows that it had, and then you suddenly want it to be part of a partition tree. Okay, so you don't have to create a table to make it a partition. Suppose you had a table which you just wanted to add it as a partition. In that scenario, this attach partition would help. But if you're creating a new partition, then you can use the partition of command which I talked about previously. So, yeah. So like you can attach a partition, you can also detach the partition. Suppose for some reason you no longer want a particular table to be a partition, but you want it to be a standalone table, then you can use the detach partition command and remove it from the partition tree. In this case, it will no longer be restricted to the partition bound. So suppose you remove the partition which was taking Mumbai previously, you have said detach. So you can now make any entries. You can put Delhi or Kolkata or anything. You can put all entries in that because it will no longer have that partition bound restriction. But all the other restrictions like the primary key, any triggers that you had created when it was part of the partition tree, it will still be present. So if you no longer want those trigger functions when it is a standalone partition, you would have to manually remove each of those restrictions. Suppose, say, this is detached. In this case, the data is maintained, but you are no longer part of the partition tree. But suppose you no longer even want that data. You want to simply delete it. Then you can, as normal, you can use the drop table command to remove the partition. So it will also detach it from the partition tree and perform a drop of the table. So you need not do detach and drop. You can simply use a drop table on the child partition name. Okay. So I'm sorry, this is going fast a bit. Yeah, so again, this is I'm just going to be talking about multi-column partitioning. Like I said, the partition key can contain multiple columns and also multi-level. Like after you have performed a partition, you will again partition the table. So looking at multi-column partitioning, this is supported only for range and hash type of partitioning. And the number of column limit is 32. In multi-column range partitioning, whenever you specify any number of rows, for each of those columns, for each of that column, you will have to mention a lower bound and an upper bound. So in this case, I have put a partition by 3 columns. So in the lower bound, there is 3 entries, and in the upper bound, 3 entries. So this means that for column 1, I'm accepting values from 10 to 500. For column 2, from 100 to 500. And for column 3, from 50 to 150. In this case, what happens is like when you're using an unbounded value, that is max value and min value, if any one of those rows, partition key columns, has the unbounded value, then all the other columns that follow it will also have the unbounded value. Like in the first case, the second column has min value, so the third column has to be min value. And in the last example, since the first column itself states that it's maximum value, then all the other columns that follow it will also be maximum value. You cannot mention a specific value for it later on. Okay, so the way the insert is performed for this particular partitioning is the row comparison operator. So all the elements of that particular row that is being inserted would be checked from left to right, and at the first unequal element, it would stop. So that is the reason why you can see, according to example, when I consider the partition 0, 0, 2, 150, this one will accept 0, 199. So you can say that for the second column, 199 is not between 0 and 50, but it satisfies the first column, which is from 0 to 100. So it you can enter into this partition. And similarly, for the second one, 100 to 49, since 100, the first column is equal, the second one is checked, and that one satisfies the requirement, so this row is also entered into this partition. But 150, this particular value is not satisfying because even the second column is equal, which is not allowed because it has to be exclusive. You cannot enter for 150. And again, 101 and 10, though the second column satisfies the condition, the first column does not, so you cannot enter into this partition. The second type of multi-column hash partitioning is multi-column partitioning is a hash one. In this, you don't need to specify a different bound for each of the partition key column. You only specify it once. This happens because the hash function is done for each of the columns involved and then combined to create a single hash value depending on which you are going to determine the partition in which this particular row has to go. So this is an example. This looks quite similar to what the previous case where a single column was used because you no longer specify multiple values for multiple columns. So again, talking about multi-level partitioning, this is when you create a partition of a partition table. So now in this case, I have already got a child. So again, I'm going to create it as a partition table. So in this case, before you had mentioned partition of parent, and then you mentioned the bounds. And you can continue this by saying partition by, and then whatever strategy and the partition key columns that you require for this. So this will continue to be partitioned. So you can create various levels of partitioning. So recently, PGBench has added few options that enable you to benchmark partitioned tables. So there are two keywords which are being added, which is partitions and partition method. So partitions has to be a non-zero integer value, and partition method can be range or hash. By default, it uses range. And you cannot mention partition method without specifying the partitions option. It would throw an error. PGBench technically has 4 tables which it uses, and one of the tables, PGBench accounts, which is the largest table that it creates, that is what is partitioned on the AID column, which is also the primary key of that particular table. So when you create a range partition using the PGBench options, what it does is whatever scale you specify, that amount of rows is split across the partitions equally. So suppose I use the scale 1, which creates 1 lakh rows, and the number of partitions is 10, then it would create partitions which can hold 10,000 values each, which is equally distributed. And the lower bound of the first partition is min value, and the upper bound of the last partition is max value. This is so that when you actually run the test, the tuples can move across in the partitions without throwing an error. So it can hold any values. And for hash partitioning, whatever number of partitions you specify to be created, that would be used in the modulo function, and then the remainder obviously will be from 0 to what is partitions minus 1. So if, again, for scale 1 and partition count as 10, the first partition would have modulo 10, remainder 0, and so on it will go, the remainder will go from 0 to 9. So the last partition is modulo 10, remainder 9. So this, I had performed some bulk load tests. So like I said, the PGBench accounts table is the largest table which is created by PGBench. So to enter such a huge data, it uses the command copy to insert into it. So I had just benchmarked it to see how it performs. As you can see, this the x-axis shows the data size across various data size, how it has performed, and the y-axis is basically the TPS. Sorry, not a TPS, the time that it took to load the data. And each of the color variation talks about how many partitions I had created in that particular case. So if you go to see, as the data size increases, the amount of time that it takes to update this partition table is a bit more. It's about 20 to 25% more than in the unpartitioned case, which is denoted by the dotted red line. And but if you go to see in one particular size, if you consider size 15, you will see that no matter what the partition count is, it is almost same. The data, the time it takes to insert the data is almost same. But when you do this for the hash partition, in this case, what happens is that there is obviously a difference when you increase the data size, but you would also see that as you increase the number of partitions, it again greatly influences the time that it takes to load the data. Now, why does this happen, you can ask. So this happens because of the nature of that partition table. When you're doing range, you are inserting, first of all, the data is inserted in sequence. So if there's 1 lakh rows, it is going to be inserting 1, 2, 3 to 1 lakh. So it is inserting in sequence. And as I had explained, the range partition, in range partition, the partitions are created in range. So it will have 1 to 10,000 first. So what happens is when you are entering, the first partition is filled. So all the data of the first partition is filled, then it switches, then it enters data in the second partition, and then it goes on till it completes all the partition. But for the hash case, because of the nature of the hash function, what happens is that the first insert, that is value 1, is inserted into partition 1, but value 2 is inserted into partition 2, and value 3 is inserted into partition 3. And this goes on, and then again, after it completes all the partition, it goes back to the first one and inserts. So what happened, all these partitions you would know are individual tables. So the partition, number of partitions I had was from 200 to 500. So for first 500 values, it has switched 500 times. The number of tables that are switched is 500. So that's the reason why the amount of table switching that happens is equal to the amount of data you have inserted. But in the range partition case, the table switching only happens, which is equal to the number of partitions that you had created. That is the reason why you see such a huge difference in the performance of both the hash and the range partition, because range denotes a very best case scenario and the hash denotes a very worst case scenario. So one suggestion would be, if you're going to do a bulk insert command on a new partition table, then please see to it that the data is sorted according to the partition key like it was for the range case, so that the difference or the time taken is minimum. But you would see even in the range case, there was about a 20 to 25% higher time taken. This is because of the partition handling that it has to do. It has to create the all the partition constraint list and then check which partition this particular row goes into. So that's the reason why you take a little bit more time. So this was another test that I had performed. Like I said, the partitioned column has a primary key which is created by default. So I manually dropped this table to see how it will perform when you don't have an index on the partition key. You may not be able to see the red dotted line, which is exactly along the x-axis because it is very low compared to how it performs in the partitioned case. No matter what kind of partition you do, range or list, the behavior is similar. Because what happens is when you run select star from pgbench accounts where AID equal to n, then it would simply select one particular partition and then scan that particular partition till it finds the row required. So as the x-axis denotes the number of partitions, so as you can see, as I increase the number of partitions, there is very good improvement in performance when I'm using Seq Scan. Now why this happens is because for the same amount of data, if I'm going to create large number of partitions, the amount of data in each particular partition reduces. And so ultimately you're performing sequential scan on a very low data. And that's the reason why the performance increases as you increase the number of partitions in this case. So this is the normal query, which is using the index, the primary index, which exists in PGBench. So this has about 50 GB of data and 10 GB of indexes. So again, the query is similar. you're just targeting one particular row. But you would see that there is a 40% drop in performance in this when you are using a partition case. Whether range or hash does not make much of a difference, but there's a 40% drop. And as you increase the number of partitions, there's a very slow decline in the performance as well. And this, again, is because of the overhead of handling so many partitions and then checking out which partition to go for each time you fire the query. This is a custom query that I had checked for. So I just tried to target about 0.2% of the rows in a 50 GB database, but in sequence. Like I had used select star from PGConf accounts where AID is between 1 and 1 lakh or something like that. So it is checking for queried range query. And in this, you would see that the performance of range is very good, but hash seems to be nearby the unpartitioned case and then slowly degrades as the number of partition increases. Now this is because in range case, you are targeting at most 1 or 2 partitions. But in the hash case, you are not only having the partition overhead, but you're also targeting all the partitions. So that's the reason why you see this difference between a range and a hash partition case. So I'll be talking about few other features which are supported and how they perform. So default partitioning, this was introduced in PostgreSQL 11. This was introduced so that you are able to catch those tuples which does not fit in any other partitions that you have defined. In PostgreSQL 10, if you try to enter a row which contained a value which is not specified for any of the partitions, it would simply throw an error that no partition found. So we introduced its default, which is supported for both list and range partitioning. And the way to create it is to say create table child, partition of the parent table, and simply say default. One downside, you would say, of this particular case is again similar to the add partition, which is that whenever you add a partition or you create a partition table for a new bound, it is going to loop over the default table which you have created and check whether it is going to violate any of the new partition bound that you have added. So suppose I have added a new partition from 2000 to 2500, but the default already has a row which has the value 2207. So now it means that that row specifically has to be in this partition, but so it is going to violate the thing, so it's going to throw an error. So to add this partition, suppose there was no problem and you could add the table, but still you would spend time in scanning the default table to check that no rows are violated. So I had just done a small case where I had a default partition in which I had just put 1 crore rows. So that took me 1,382 milliseconds to simply add a partition. But when the default partition was near empty or very few rows, it just took me 2 milliseconds because the amount of time to scan that table is very small. Runtime partition pruning. This was also introduced in PostgreSQL 11. And this is performed at 2 levels, at executor initialization and then at the actual execution. The new parameter that has been added is enable partition pruning, which is default, it is switched on. So when I say executor initialization, it usually means the prepared query that you create a statement using the prepare command. And when you execute the query, it would know it would have an already prepared plan, but when you are trying to execute the prepared statement for a particular value, it would determine which partitions it can choose for that particular value. So as you can see, when I said execute for value 1500, it determined that it does not require 2 out of the 4 partitions that were in that table. So it specially mentions subplans removed 2, and then only scans the 2 partitions which satisfy this particular criteria that I have given. This is the actual execution case, the second type of runtime partition pruning that can occur. This happens when you're using nested loop joins. So I'm going to first talk about the unpartitioned case, how it behaves. So I have got two tables, one contains 6,000 rows and another contains 4,000 rows. But there are only 2,000 rows which satisfy this join condition, which is column 1 equal to column 2 in the second table. So this one is satisfied only by 2,000 rows. So when I run in an unpartitioned case, it loops 6,000 times in the second table to check, to perform the join. And the time taken is about 15 milliseconds. Similarly, but when I do it in a partitioned case, when I'm doing it in a partitioned case, I have, you can see here first, the table, L table has got 6,000 rows, and it tries to look for 6,000 times. But it checks in the partition whether it satisfies the given row value that has come in from the L table. So ultimately, the first partition P1 is only scanned for 1,500 times, and the second table is never scanned because none of the values in the outer table satisfied the rows of this table, so it did not bother scanning it. So, and that is mentioned by never executed, which means that this particular partition was never scanned in this particular query. And then P3, the third partition, was only scanned 500 times because only 500 rows in the first outer table satisfied the condition of this partition. So in this smaller case, I was able to see a drop of about 30%. So this can, of course, increase as the number of rows are there increased and how it behaves. It depends on the kind of entries that you have. Okay, so next I'm going to be talking about partition-wise join. This was again introduced in PostgreSQL 11, and this also has its own parameter, which is enable partition-wise join. But this is by default off because in many cases it can create a lot of planning time can increase. So if you feel that for your particular case it is important, you can switch this on. One restriction to perform partition-wise join is that both the tables involved has to be partitioned, and the partition bounds of both the tables should match. So if I say one partition is 1 to 20, 20 to 30, and 30 to 50, then both the tables has to have the same partition bounds. Only then it can perform this partition-wise join. And okay. So this is a case in which I have not enabled the setting. So in this case, I have tried to join tables with 4,000 rows and 40,000 rows and 20,000 rows. So it first scans all the partitions of the first table, and then it performs a hash join by joining all the all the rows of the second table. And this is, in this case, had taken me about 37 milliseconds. Now, when I enable the partition-wise join, which is equal to on, you can see that it performs the hash join, the same type of join that was performed previously, but it performs for each of the partitions. So A1 and B1 is joined, and then A2 and B2 is joined, and this is repeated for A3 and B3 and A4 and B4. And you can see there's almost a 50% reduction in the execution time for performing this kind of join. Next is partition level aggregation, again a feature of PostgreSQL 11. This also has its own parameter, which is enable partition-wise aggregate, which is off by default. So when you use group by or any aggregate function, which uses the partition key, then the aggregate function is pushed down into the individual partition. And suppose it is not on the partition key, then what will happen is a partial aggregate is performed, and then you combine it at the upper level. So if suppose there's a foreign table in between, then this aggregate functions are pushed down to the foreign table. So in this case, this is a non-partition case. So I have tried to perform a group by function, group by command, and this will simply call an append node, which is going to scan every partition and then perform the aggregate function group by. So this, in my case, has taken 11 milliseconds. And then when I set the parameter enable partition-wise aggregate equal to on, and then I perform the same command, then what has happened is that for this aggregate function has gone down into each partition. So it has been performed for P1, and then it has also been performed under P2 and P3. Now the thing is that since this command has been called on the partition key, you know that when you are in a particular partition, you're going to get a unique entry. So that's the reason why there is no final node which is going to combine all the results. So you just directly get it from each partition, and this has kind of reduced it about 20% my execution time. So now this is the case where I'm talking about where I'm not using the partition key, which means that the rows of a particular value can exist in different partitions. So even in this case, it does provide some help because it provides partially it checks, performs this aggregate function within the partitions, and then finally it does final hash aggregate to combine whatever duplicates it finds. So as you can see, this two partitions has got the value A, so it performed the aggregation there for 10 and 5, and then finally when it came out, it was able to combine those to create one row saying A equal to 15. So in PostgreSQL 12, we had certain features to check out what the partition tree information to get out from the partition that you have. So when you say PG partition tree, it would display the entire partition tree in a table format. Then if you say PG partition ancestors of a particular table, then it will display the ancestors of that particular partition till the root. And PG partition root would display the topmost root of a partition tree. Yeah, so this is just an example. So when you say PG partition tree, it shows it in a table format, the partition tree, and also gives you certain values. So in this case, P11 is further partition, though it does not currently have any partition to itself. It is a partition table, and that's why the isLeaf column says P1 is false, because it's not a leaf, it will have children. So, and then the level specifies in which level that particular table is. Like T1 is level 0, P1 is level 1, and P11 and 12 are level 2. And the parent rel ID is its immediate parent of that particular table. So PG partition root, like if I say give me the PG partition root of table P12, then it will say the topmost root, which was T1. And if suppose I want to check the ancestors of my current table, then if I'll have to just say select star from PG partition ancestors, and it gives me in the reverse order. So starting from P12, then it went to P1, and then T1, which was the root. So I would like to say that partition does help in a lot of scenarios, but not in every command does not become faster. So just know your data, know your system, experiment, and try to find the best partition parameters for your system before you just don't blindly partition. So that is it, and we are currently hiring, so you can connect with Akshay at EDB booth. That's all.
Thank you, Beena. Any questions? Just a minute, just.
I'm sorry.
The set commands you have shown, set group by aggregate. Yeah, that is a user session level or a global?
Yeah, user session, or also you can set it on a PostgreSconf as well.
Conf also?
Yeah.
Okay.
So you can have it for the entire system.
For all the partitions you said, we have to create the child tables explicitly, right?
Right.
Say we are planning to have some partitions where it will have thousands of partitions, and creating all the partitions manually will be a cumbersome thing. So is there anything?
Currently in the core we don't have any automations, but EDB Postgres is working on it. So not in the open source code, but EDB has its work. We are working on it.
In the multi-column partitioning, so how the pruning happens? Like if the first column in the filter cloud does not contain the first column or the second column, there are multiple columns, right?
Yeah.
So it is able to prune partitioning correctly?
Yeah, so when you have where clause which uses those 3 columns, then it would perform the pruning. But if you mention one, so it would work in range partitioning. In range partitioning, it will be able to select the partition column according, like if you have where clause, column 1 equal to something, then in a range partition case, it will be able to prune the partitions. But if you say column 2 equal to something, then it will not be able to perform the partitioning properly. Yeah.
Okay. Thanks.
How do you partition in an existing table that's been like really large? Okay,
if you have an existing table which you need to partition, it is not currently possible. You will have to create a partition table using partition by command, and then you will have to copy the data manually. You don't have direct, you cannot create, because partitioned table cannot contain any data. So
how do you manage that from an application perspective?
So like basically you will have to first have a log. So there will be some amount of downtime, of course. So you will have to create a partition table, perform the copy, and then go online, because otherwise there's no other way you can do it.
Yeah.
Actually didn't get your question.
Yeah, hi. Actually, I would like to know, can you attach the child tables to more than one parent?
Can you attach the?
I mean to say...
okay, can one child be for 2 parents?
Yeah.
No, you cannot do that. It has to be, in hierarchy, only 1 parent is allowed.
So that means if you're going to, I mean, without removing, if you add to some other parent, does it throw some errors?
It would. You cannot attach it. It would probably throw some errors. Yeah.
Okay, thank you.
I have 2 questions. One is, I partition using a key and joining with another key. What will happen? Whether partition will help us or it's a normal join only?
So you're saying you have a partition table, okay, and the join condition has the partition key of that.
No, join is not the partition.
Join is not the partition key.
Yes.
Okay, then it would not help, because you would basically be scanning the entire partition.
In that scenario, if in the where clause, if I put the partition key, then only that portion of that partition only will get joined, or the entire thing will get joined?
Actually, I'm not able to get 100% question. So you're saying I have a partition case and an unpartitioned tree, unpartitioned table, and now I'm trying to perform a join.
Yes.
Okay, so you're saying depending on, so it could help because the scans performed on the partition table would be determined by the rows on the unpartitioned table.
My question is whether the first table will be joined with only the child partition or the entire partition.
You mean the parent or the only? So it will only select the. It will join with the entire. It will show join on the entire table, but internally it would only perform join on the partitions.
And next question is, what about foreign keys?
What about foreign keys? Like, in which?
Is it possible to implement foreign key in
yes,
partition?
You can currently have foreign keys.
In 12 or even in 11?
No, from 11 you can have foreign keys.
Okay.
I would appreciate if you discuss with Beena offline, because we have to move on with the next presentation.
Yeah, I would be waiting at the EDB booth. If you have any queries, you can meet me there. Thank you.
I'll just